Running out of time.
Okay. I ain't even watched a movie since I've been there.
Heating and AC test 13. Heating and AC test 13. What we're going to start out with here. And I'm going to say technician A says a faulty heater operation can be caused by a faulty engine cooling system. Is he right? He is, isn't he? Technician B says a complaint of insufficient heat can be caused by someone not filling a cooling system properly. If there's air in there, you're subject to have issues. That's going to be a C. Technician A says a heater core leak can be the result of the coolant wearing a hole through the core. Technician B says a core leak can be caused by chemical action eating a hole through the core. Both of those guys are right too. Technician A says a heater core leak can be the result. Excuse me, that's wrong. Technician A says a heater core inlet hose is connected to the water pump inlet. Technician B says the heater core inlet hose is often bigger than the outlet hose. Wow. That's a D. Neither one of them guys are right. To begin with, the heater core inlet hose is connected to the hose that, the heater hose that comes from the water pump area. And even when the thermostat's not open, you're still going to be getting water through your heater core. And so, because they want that hot water to be going to the heater, they want the heater core to get hot before anything else does. And then the heater hose outlet is the bigger one. If you run the heater hose into the bigger one, then you're going to cause pressure to build up in the core, because you got a smaller outlet and you do an inlet, you're basically going to create pressure. Let's see, insufficient heat input from a heater can be caused by what? A, plugged core, B, airlock, C, faulty thermostat, or D, any of these. If somebody complains that their heater's not working right, and you look at and they come in with a car and it's nice and hot and they just drove it from Columbus, and both the gauge on the dash and your scan tool are telling you that it's running about 160 degrees, you're going to have to replace the thermostat and get the heater back up. But I will tell you this, you're going to usually see like a PO128 code or a PO125 code if your thermostat is not working right and if the engine's running too cold. The engine controller does not like the engine run too cold. 128 and 125 are typically indicators that the engine's running cooler than it should. And that's bad for emissions, it's not good for the engine and everything else, because you want it to run about 200 to 210. Some people are scared of that, they think colder is better, but no. The warmer it is and the more vaporized the crankcase steam is, and a whole host of other things going on. You get better fuel vaporization whenever it's running good and hot, but also, the sludge that you see in the crankcase a lot of times is because they're not running hot enough. If you go on it's running too cold, it ain't good because it'll sludge everything up. Technician A says faulty cable adjustments cause improper heat and AC operation, when they're talking about the cable that operate the doors and stuff. Technician B says a broken vacuum hose can do the same thing. Who's right about that? Both of them. You got that? Faulty cable adjustments or a broken vacuum hose. Because a vacuum hose, basically, if it's operating a heater control valve or if it's driving your blend door or whatever, you'll have issues like that.
So 4 was thermostat?
4 was thermostat, yeah. Well, a 4 was actually any of these. 4 is actually a D. Let's see, vacuum motor should do what? A, move when vacuum is applied to the port. B, hold a vacuum. C, A and B, or D, neither A nor B.
C.
That's 6. 6 is C, both A and B. And this is basically, let's see, vacuum motor, this thing right here. We've actually held this up in front of our camera before. Let's see if I apply vacuum, it goes like that. All right. Let me see here. Typical intake manifold vacuum readings at idle or what? Somebody should know that. You guys have been in here on some of your engine performance stuff.
10 to 12.
Come on. You're talking about manifold.
More than 30.
What was that?
More than 30.
You can't have more than 30 inches of mercury. That's impossible.
You can't?
No, it's impossible to have more than 30 inches of vacuum. Because that means there's no air at all.
18 to 20.
How about 18 to 20?
Okay.
That's where you look at that on the vacuum gauge that we plug in to do it as a tool. That's where the needle is waggling along in the green at about 18 to 22 or something like that. Vacuum diagrams generally contain all of the following except what?
Hose cutters.
No, vacuum temperature readings. What a dumb thing, vacuum temperature readings. Who came up with that? All right, let me see here. Uh-oh. Never mind. Okay, a vacuum check valve is used to do what? Number 9. Some of you got, me and you worked on one, remember?
Used to keep vacuum from going back.
Yeah, it's basically to maintain it in the vacuum reservoir under high load and speed conditions. Technician A says the thermostat that opens too soon can cause poor heater operation. We've already talked about that on the previous question. Technician B says low coolant level can cause it. That's right too. Under what conditions should vacuum readings be taken to test supply vacuum for the actuators? That's engine running. Engine running. B. Testing most vacuum operated controls requires what diagnostic tool? Got any idea? Both A and B. Vacuum gauge and a handheld vacuum pump. You don't need a pressure gauge to measure vacuum stuff, right? Even though the vacuum gauges a lot of times, will have pressure on one side, vacuum on the other, it doesn't vary much. You don't use the pressure side when you're checking vacuum stuff. After the water pump was replaced and the cooling system refilled with coolant, the heater stopped providing warm air. What's the most likely cause?
Heater stopped, huh?
Well, it was only after. It was only after working before, fine. It was the air pocket trapped in the heater core. That's why you need to turn it on heat. Turn the heater on. If the heater was working before, it'll be working when you're done. If the heater ain't working when you're done, you got air trapped. Or you're not full of coolant, you think you. But it scares the daylights out of me when we do these exercises where we're draining the coolant system, refilling it, putting a thermostat in or whatever. And I look up after I see them putting the thermostat in and putting the hose back on it and pouring some coolant in there, and 5 minutes later they walk over here and tell me they're done. That's a joke. You got to keep that thing. You got to, if you're competently doing this, you're going to spend at least 20 minutes making sure, probably 30 minutes, making sure that thing's kicking the fans on and off and that it's warm. I mean, that the coolant's flowing everywhere it's supposed to. I mean, if you just, I'm done with this, I poured it full of coolant, I'm putting it outside, that's when they overheat and it burns up. They take a cap off and it sprays hot water all over, they get 30-degree burns, and it's your fault. Do not do that.
I open the lid and spray them, it's our fault.
Yeah, because they're going to be scared that they're burning it up, and some of them don't know any better. And if they jump out, I've seen one of the, what'd you say?
When you put down for you do it in the
Lock that cap on.
neon?
Yeah.
Neon?
Yeah.
What is that?
What happened there?
We only put water back in it when we.
Well, now, dagnabbit. It's going to get all rusty and it's going to ruin everything.
What?
You just put clear water back in that neon.
Put the heat core.
Oh, you only put water in there?
Yeah, we put back in.
Well, that wasn't the neon, that was escort.
Oh, that's good.
That's cool. That's
Yeah,
cool.
okay. You need to put some antifreeze in there, because it may sit out here and it may bust the block. It's also going to rust everything. That would be good. That antifreeze protects the metal on the inside. It keeps it from corroding away. All right, now we got right here, that's one of our trainer cars. I mean, it doesn't really, it's not like it's the kiss of death. Oh, well, I can't blame him for being a second-rate amateur. All right, let me see here. A lack of heat from the heater is being diagnosed. What's the most likely cause? Partially clogged heater core, yep. Did you know that rust can be so fine that it can just clog it up, look like clay? Heater hoses are attached to the core using what? Both A and B. Quick connect coupling. Now, I will tell you this, on that Ford F-150 the other day that we were working on, that heater core, that Chinese-made heater core we got from the parts house, those lines wouldn't go on there. I mean, they were real close to the right size, but they were just seized up tight trying to go back on there. And if you ram them on there because they're way up under that cowl and you can't see good, if you got any idea that those things may not be snapped on there, you better take those fittings off, put the hoses on there, and put some clamps on them. You know what I mean? With a lot of these parts we're getting nowadays, the parts that are coming out of China have got the specs are a tiny bit off. Like sometimes you'll get a Chinese-made power steering pulley, and you're trying to put it back on your power steering pump, and it just will not go. You absolutely will not get it back on there unless you take a small 2-ear brake cylinder hone and run it down through the center of that pulley and make it a little, bigger than it was. I mean, just be really careful about that. If it's not the factory brand, or if it's like if you bought it from the parts house and it says made in China on the box. I don't have anything against the Chinese folks or nothing like that, but a lot of the stuff that's coming from over there is not quite built to spec. This friend of mine that's got that shop over there between here and Dothan said that he's seen power steering lines that have a sort of a joint in the middle of them. He'd buy one and he'd put it on there, go to all the trouble, put it on there, as soon as he cranked it up and turned the wheels both ways, poof, it popped that joint apart in the middle of the line because it wasn't built right. And you get another one because they call the parts out, we'll send you another, send another, poof, it does the same thing. And so he wound up having to get one from the dealer, which was a factory model, but it was Chinese-made power steering line. You know, some of the stuff you give from China is okay, like brake rotors and stuff. If it's got to fit a certain way, real tight tolerances. I don't, you know. All right, so let me see. Let's see. The complaint is poor heater operation. The top radiator hose and both heater hoses are at 160, not 100, 16 C. That's cut off on the end. It looks like 16 CF. 160 degree Fahrenheit. Technician A says this problem is caused by plugged heater core. Technician B says the thermostat must be stuck open. 16. That's going to be what? What do you think? Technician A. I'm not going to say that it's stuck open, but I am going to say the thermostat's bad. The answer key wants you to put D on that. I don't know what the rationale is behind that question, but I didn't write it. Technician A says a plugged heater core can be cleaned by filling it with ammonia. Technician B says the best repair is replace the heater core. Which technician is correct? B is correct, obviously. The AC performance test shows good high and low side pressures, but the air discharge of the ducts is not as cold as it should be. This could be caused by what? A, leaky vacuum hose. B, misadjusted actuator motor. C, a blend door not closing completely. Or D,
Any of them?
that's obviously going to be any of the above. And we got a couple of true-false questions on the tail end of this test. This one here, the plugged cabin air filter can cause engine overheating. Is that false or true? False.
False.
Plenum inlet chamber filter is usually under the hood, inside the engine air filter box. No, plenum inlet air filter. That's basically we're talking about air conditioning now, not, you know, engine air filter. So that's going to be a false one too. Now let's see how quick you can do this right here. Let's blow through this next one here. It's only got 25 questions, so we should be able to do that one quicker. Even though the test we just did had 20 questions. You guys ever play 20 questions?
Yep.
Have a good time? All right, let's do it. Jump into this thing, right? Let's make it happen. All right, we've only been in here 12 minutes, so you shall not surely die.
Shall not.
All right, choose one alternative that best completes the statement or answers a question. Which of the following is the unit for electrical pressure? Wait a minute, electrical pressure.
D.
Remember, voltage is pressure. Yeah, voltage is pressure. Amps is flow. Ohms is resistance. So how much is flowing is amps. The pressure that's pushing it is volts. That's why we got to take the 12 volts and jack it up to like 100,000 volts to jump a spark plug gap, because it's going to pop through that, you know, that air blanket. All right, watts is basically volts times amps. That's how much power is being consumed. Okay, now let's look at true, false, right? True if the statement is true and false if it's false. Most automotive electrical systems use AC current. Come on now. Willie, you're messing with me now. Everybody knows that's false. There's some alternating current flying around on the car, but most of it ain't. Choose the one alternative that best completes the statement. Fusible link is usually 4 wire sizes smaller. It is than that particular circuit. Fusible link is it's made out of special, it's got special insulation, it's made out of special wire. And it's basically, it'll take a surge without blowing a fuse. As soon as you surge it, pop. But on a fusible link, it can take many a surge before it finally pops. If you got it dead short, it'll burn in 2. But if it's got some surges, it won't what?
Aren't the HID lights run by alternating current? Isn't that why they have that ballast?
Yeah, it's basically, the ballast is actually jacking the voltage way up.
Doesn't that change the alternating current?
No, it's just basically changing it. You know, so it ain't alternating current coming out of your coil, you know.
Yeah, but doesn't it like transfer?
It might. I'd have to study that, but I don't see why it would need to.
I think it does.
Yeah, I mean, it's possible, because it would be brighter with AC current than it would DC, so you may be right about that. I'm not going to categorically say that you're wrong, but
Okay.
I may not. You might be right, but I don't think so. I could be wrong about that. I don't know. I haven't extensively studied high-intensity discharge lights, other than the fact that I know there's a ballast there, and it's jacking the voltage way up high. I mean, like through the stratosphere.
It's supposed to be like
68,280 million volts or something like that. It's just really high, you know. It's really
it's
high.
also supposed to take less power.
Yeah, it does. It does.
It's like 10 times brighter.
Yeah, it's really bright, but
They're bright as
I
hell.
don't like those. All
You
right,
don't
so
like bright lights?
no, that because it causes issues. All right, which of them? I don't like to see them coming. You know, them bright lights. I don't like that.
You can see so far. That
Yeah.
You can't even zoom. They're like,
Well, the headlights are there so people can see the car you're driving as much as they are that you can see. You know what I'm saying? That's part of it.
yeah.
They got to be able to see you coming. And
Yeah, them lights you can see like over the mountain.
I had a cousin that got killed because a guy driving with no headlights on out in Texas back in the early '60s. and just bam, ran head on into him. No headlights. He didn't even see the guy until, you know.
Was it
All right.
nighttime?
Huh?
Was it night?
Yeah, it was at night. He couldn't see the car. All right, let's see. Which of the following is considered an output device in an ATC system?
I meant like.
What's an output device? Which of them? Which is an output device?
It's gonna be a blow motor, gonna be.
Both A and B.
Yes, but,
Which of the following is monitored by a sensor in the ATC system? In-vehicle temperature, ambient temperature, sun load sensor, all of these. Fives, all of them. Okay, it's going to be true, false. Electrical mode doors in an ATC system usually have a feedback sensor string connected to them. That's true. Which of the following test instruments can be used on any automotive electrical circuit? Analog multimeter, ohmmeter, digital multimeter, or a test light? C. Modern electronic circuits can be damaged by what? Rough handling, excess heat, electrostatic discharge, any of these. That's true. You know how much voltage is coming out of your finger? You know how whenever you grab something and it pop, it gets you? Like if you're walking on that's from 8 to 25,000 volts.
holy crap.
It's coming out of your finger. I ain't kidding you. That's how much, that's why it jumps that gap. But when it comes out of your finger, if it goes into that electrical circuit on that electronic part, it's done. You know what I mean? So you gotta be careful about that.
So like,
Now,
don't they have like a little grounding thing you put on
you can actually put a wrist strap on and ground it to the case before you ever do that, so that you don't do that. That's why you don't set a gas can in the tailgate in your pickup truck, and and bring it and put the gas. Like if you got a metal gas can, you're setting it in your pickup. As soon as you go to stick that thing in there, with those gas fumes, boom, stuff catches fire like that. That's why it says always have it on the ground instead of having it in the truck.
Now, what if
Yeah, you can discharge static electricity from that gasoline hose, and that is not a pretty sight to see.
Now, what if you
Sometimes
do it in the back of like an SUV, like when you open the hatch?
it could explode and blow you completely away. So always set it on the ground. Don't ever do it unless you got to sit on the ground.
Yeah, but that would be.
But think about what's at stake. You know what I mean?
I know, but
I'm just trashing this idea. I'm not going to pay attention to what it says on the pump. I'm going to fill it up in the back of my SUV. Boom! Well, Zach was a good old boy.
well, think of how it would be.
You know what I'm saying? Now, I understand your logic, but sit the dadgum gas can on the ground. Do not fill it up sitting on anything else.
I don't sit it in my garage, but on the ground.
Second rate amateur.
Did you
Okay.
know, like, girls?
I see where you're going with that,
This
but
is what I took a picture of on a pump. It says, please be sure the pump nozzle is in your tank before you begin the fueling process.
yeah. Yeah, and yes, we know the gas pump is busted. Okay.
Did you see that plant that they shut down that made the jugs, the gasoline jugs?
No.
Yeah, they lost like a couple hundred workers. They've been working there for like 30-something years.
They stopped making gas cans?
No, like some lawyers were suing the company, and they had like 25 cases a month they were going through. And
Good
losing
grief.
Millions and millions of dollars, and then they went bankrupt.
Something happened with the design on those things. All right, let's get through
They
this.
were catching on fire when people were trying to pour the gas onto a fire.
Yeah.
So they got sued because of that.
Yeah.
If you're doing this to a fire with a gas truck,
Yeah, well, you don't need to be doing that anyway.
They were saying that the gas jug wasn't safe, that the fire went back into the jug if you were doing this over a fire.
Yeah, there's all kinds of people that aren't supposed to be handling it. Some people just should not handle a gas can. All right. Let me see here. Electrical mode doors in an ATC system have to be, we already done that one there. Let me see. Which of the following is true concerning ohm meters? Ohm meters cannot be used to check continuity. Is that true? False. Ohm meters can be used on a live circuit. That's false. Don't use an ohm meter on a live circuit. Got me? A rule of thumb for clutch coil resistance is what? Now, somebody in here measured clutch coil the other day and got a
You're done
resistance.
with that question. You
Huh?
only got to B.
What?
You only said A and B, and you can do C.
I know, but when we came to the right answer, which is the following, oh, excuse me. I said not true. Excuse me, self-powered, number C. C is what 9 should be. I'm sorry. I did that wrong. A rule of thumb for clutch coil resistance is what?
Hey,
On number
3 to
10.
5.
3 to 5 ohms, that's right. Somebody was in here the other day, we were measuring that on a worksheet. A vehicle with an ATC system has heater and a defroster operation, but the AC is not working properly. To diagnose this problem, a technician should do what? Automatic temperature control. You're going to check for trouble codes to start with. First thing you're going to do, there'll be an off and warmer thing that you mash or whatever. You just look it up in the book, and it'll show you. Usually, it'll run through a test and it'll show you on the dash. Number 12, an example of a short circuit is a burned wire with a bad insulation that touches ground. Isn't that right? What about a clutch coil with resistance of 0.5 ohms, or what about a burned out light bulb?
All of them.
You think so? That's actually going to be B.
Really?
Yeah. Now, I don't know why they said they put A on there, because A sounds to me like a good answer to that question. But basically what we're looking at is a clutch coil resistance of 0.5. That's what their answer key is. I want to talk to these people who wrote this book. Something's wrong here. They're poorly written questions. Some of them. Now, the blower motor that runs on high speed only indicates a faulty what?
Relay?
Resistor bank.
That's what I meant.
High speed only. Got me? Not the relay. If it doesn't run on high speed at all, that's probably going to be a relay. See that? Because the relay is actually what throws it the other way on most of them. That's, you know, blowers are wired up separate ways, but anyway, if it only runs on high speed is the only speed that bypasses the, you know, resistor. Blower motor stopped working on all speeds. Technician tested the blower by touching a jumper wire from battery positive to the blower power terminal, and the motor did run. Technician A says the blower motor should be checked using a fused jumper lead to test for excessive current draw. Technician B says resistor pack and or relay are likely to be defective. Some of those questions are so long it's hard to parse them. You got to think about what you're reading. Both technicians on that one. A blower motor is drawing more than a specified current. Technician A says the blower motor ground connection could be corroded. Technician B says the blower relay is shorted. Who's right about that?
Both.
That's a dog. Neither technician.
Close.
Drawing more than a specified current. Now let me ask you this. Why would you check the ground connection if it's drawing more current? If it's running too slow and it's not doing it right, your ground connection could be a bad connection and cause it not to run. But a ground connection is not going to cause it to draw more current. It can cause it to draw less and not work right. So, all right, let's see. Which of the following might cause excessive circuit resistance?
Shorter ground.
Short to ground? No. Resistance. Shorted motor windings, weak battery, corroded switch. Corroded switch. Corroded switch. You knew that. The current flowing through a circuit is measured in what? Watts, ohms, volts, or amps?
Watts.
Come on.
Wait, say that again? What did you just say?
The current flowing through a circuit is measured in watts, ohms, volts, or amps?
Well,
Amps.
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 Second guess. He got it. He gets 50% credit on that question. Okay, the resistance to electrical flow through a component is measured in what? Watts, ohms, volts, or amps?
Watts.
Come on.
Dude, why would you keep saying watts? None of these are really watts.
I want to try.
He's just throwing a monkey in the wrench. Ohms. The resistance to electrical flow is measured in ohms. The conductor has an infinite resistance if it is what?
Closed.
Opened.
Open.
Open.
Closed.
All right. Technician A says most late model control systems allow the system to communicate with diagnostic test equipment. Technician B says most late model control systems can run pre-programmed system diagnostics and generate trouble codes. All right. You know, basically, you push the buttons on the dash. Both technicians are right. Push the buttons on the dash, you'll get that. You know, on them Cadillacs for years, they had a scan tool built into the dash. On the AC, you could actually mash a couple of buttons on the AC and you get trouble codes and go through looking at all your PIDs and all that. And I don't think anybody but Cadillac did that. That was pretty cool stuff. What type of circuit is shown here? What type of circuit is shown here?
Series.
Huh? What is that?
Series.
That looks like a series to me. Doesn't it to you? What do you think about that? Number 22? That's a series circuit, but if you want to talk about it, everything is actually going through. There's nothing parallel about it. Okay, and this right here, obviously the next one is a parallel circuit, if I can find the right one. That is a parallel circuit, isn't it? Got me? Okay, we're almost there. We'll have another 20 minutes to work on Larry's car some more. In this schematic, what will be the voltage displayed on the DVOM?
Hey.
What voltage are you going to get on the DVOM on that one there?
B. A or B.
Huh? What do you think? Anybody know?
Easy.
Let's look at all of our answers down there. What are they?
It's on ground and a wire, man.
Huh?
It's on nothing.
I don't know.
You're going from the ground to the wire. Where's the battery at in this thing?
There's not.
Way over here. Yeah, it says B plus on it.
Huh?
That's why I said there's not enough information.
There's no battery.
It says B plus.
All right. Approximate voltage on the DVOM. All right. Where are we at?
We're on 24.
Where you at?
Okay. Well, we're on 24, but think about where we're at. So where is our battery? Our B plus. Look where our B plus is. Our B plus is coming in on the bottom of that rail. On that rail on the bottom. See that B plus coming in on the rail on the bottom?
I already told you.
All right, and it's going up through that relay, isn't it? Is the relay closed?
Matt doesn't have to be close.
Is the relay closed? Is it closed or is it not, guys?
I don't.
Don't play dumb with me. Huh?
Yes.
Is the relay closed? No, the relay is not closed. Look at it. Draw your line, man. Look at that. Battery's going up here. It's going to a terminal. It ain't got. There's nothing making it to that.
No wonder it's not working.
Not enough information, is that the answer?
Yeah.
What? Is it really?
I don't know, I think it's
For 24? About. It says about 3 volts, but I don't believe that. You know why? Because they didn't draw that with that relay closed. That's a badly written question.
You know what?
See, the right answer is not there. They're saying there's 3 volts there, but no.
I knew it was D.
No, but I mean, no. There's enough information here, but the right answer is not on the thing. That is a poorly written question. That's 3 poorly written questions I found on this battery of tests. I'm going to have to talk to them about this. All right, let me see here. The answer they're wanting you to put is A, about 3 volts, but that relay is not closed. I'm sorry. It's not. All right, number 25. Look at there. Look at that question right there. See it? All right. Because in this diagram, the blower motor is A, not running because the relay switch is open, B, running at low speed, C, not running, or D, not enough information. That's supposed to be B, running at low speed. You got me? Well, I'm taking that back. I was wrong about that all the way around the line because I was looking at these things wrong. Look at the battery. We're coming off the battery through the switch. Most of the blower's hardwired to ground. So don't quote me about the people in the book because I was doing this too fast. But there is voltage flowing through the low contact on that switch. And it is going through all of those resistors. It is. You got me? Even though the relay is not closed, basically the normally closed terminals are carrying power to the motor. So yeah, basically what you're looking at on that one is a B. It's running at low speed because it's on the low side and the power is being fed through all of those 4 of those resistors. So I apologize to the publishers of the book because they wrote a better question than I gave them credit for. Sometimes we make a mistake. Now, if I'm somebody that claims I never made a mistake, one time I thought I made a mistake, but then I found out that I actually didn't, and so I was wrong about that. All right, that's the end of our class today.